Hi and welcome to the lesson of multivariable calculus. In this class, we are going to learn how to test a field for conservation. Now, if we are given with a field f, which is governed by functions p and q, for instance, we are dealing in a plane that is R2, then if these functions p and q are continuous and their first partial derivatives are also continuous in a given region R, then we can test it for the conservation by using this equality. And if this equality holds, we can say that the field is conservative, right? Now let us take some example. For instance, we are given a field that is given by yi plus xj, and we can see that this function y, that is p, and this function x, that is q, they both are continuous throughout the plane R2, and their first partial derivatives are also continuous. Therefore, we can test for this equality, and we can see here that both are equal. Therefore, the field that is given is a conservative field. Similarly, we can uh, evaluate this example as well. If a field is given that is given by these two functions, that is x squared minus 2y cubed I plus x plus 5y j. Now this function is p and this function is q, and we can see that both the functions are continuous, and their first partial derivatives are given by partial p over partial y is negative 6y squared, and partial q over partial x is 1. So both the derivatives are also continuous. But we can see here that the equality does not hold for this field. Therefore, we can say that this field is not a conservative field, right? Similarly, this is another example. The field is given as negative y times e to the power negative xy minus x e to the power negative xyj. So this is p and this is q. We can find partial p over partial y, partial q over partial x, and then we can see whether the field is conservative or not. Similarly, we can test the field for higher dimension as well. For instance, if we are given a field in R3, let's suppose the function is given by pi plus qj plus rk. So we can test it by doing partial p over partial y equals partial q over partial x, partial p over partial z equals partial r over partial x, and partial q over partial z equals partial r over partial y. So all these three equalities should hold for a field to be conservative in R3. And similarly, we can say that uh, the curl of this vector field should be equals to 0. Therefore, one more way to define a conservative field is that the curl should be 0. So we can say that the field is conservative, right? Now let's take an example in R3. So for instance, okay, we have this function. Let's say this is the field, for instance, f equals y plus y z I plus x plus 3 z cube plus x z j plus 9y z squared plus xy minus 1k. Now to test whether this field is conservative or not, we can find the curl, and simply if the curl is equals to 0, then we can say that the field is conservative, right? So we can find the curl, that is del cross f is given by this determinant I, j, k, partial over partial x, partial over partial y, partial over partial z, and the functions p, q, and r. So we can write here, this is I, this is j, this is k, this is partial over partial x, partial over partial y, partial over partial z. So this is y plus y z, x plus 3z cubed plus x z, and this is 9y z squared plus xy minus 1. Now we have to find the determinant here, therefore uh, let us just do it here. We have to erase this for some space for computational work. So this is I times partial over partial x applied to, sorry, not partial over partial x, but partial over partial y. Partial over partial y applied to 9y z squared plus xy minus 1. Then minus partial over partial z applied to x plus 3z cubed plus x z. And then we have minus j times partial over partial x, 9y z squared plus xy minus 1, minus partial over partial z applied on y plus y z, then plus k times partial over partial x applied to x plus 3z cubed plus x z minus partial over partial y applied to y plus yz. Now we can compute this and see whether this goes to 0 or not. And if this is 0, then we can say that this is the field is conservative. Otherwise, we will conclude that the field is not conservative, right? So this Dawa P over Dawa Y. So this is P, this is Q, this is R. Okay, so Dawa P over Dawa Y is equals to 1 plus Z. And then we have partial Q over partial X equals to 1 plus Z. And then we have partial P over partial Z equals Y. That is also equals to partial R over partial X. And again, partial Q over partial Z equals 9Z squared plus X. That is equals to partial R over partial Y. So these equalities hold, therefore we can say that the function given is uh, conservative, the field given is conservative field. So this is how we can compute for the conservation of fields. Thanks for watching the lesson. That's all for today.